Hey there. So we're going to do a really quick primer on how to address the direction of the product from a cross product. And we call this the right hand rule. We call it that because we need to use our right hand. It does not work if you use your left hand. We're going to keep using the right hand rule in Physics 2 next fall. So if you're taking that, hold on to this information. It's really useful. Anytime we're doing cross products, we can use the right hand rule. So the right hand rule uses all 5 fingers. So there are many ways to do the right hand rule, and I don't want to lock us into the only way and fool you into thinking it's the only way. At the same time, I'm going to be pretty consistently using this one way in class to provide that consistency. So if you're familiar with a way to do it, maybe from a high school physics class or a different physics class that you took in college, and you feel comfortable with that, hey, use what you feel comfortable with. Use what you know. Use what will give you the right answer, but make sure that it is correct. All right. So if you want to talk about, if you have a preferred way that isn't the way that I'm about to go through this, just talk to me in office hours to make sure that it's equivalent and that we're feeling good about it. So the way that I like to do this is we have our fingers and our thumb. Our thumb, in this case, is not a finger. That's some debate. It's a digit, I suppose, but we're going to talk about our fingers. We're going to bend our fingers, and then we're also going to have a direction of our thumb. Some people use the bending of the fingers. They'll just use your palm. That's fine, I suppose. I think the kind of very, very almost a visceral nation of kind of instills in me some sort of process, right? So the way that I like to go about this is that R, or the first thing, if we think about A cross B gives me C, in this case it's R cross F gives me tau, but R, our first variable, our first vector, is going to be our fingers. We're going to point our fingers in the direction of R. Now, I do want to point out, I can point my fingers like this, 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 right? There are many different ways to point my fingers up. And I point that out because we have the directional aspects of how I'm going to flap my hand, right, and how my thumb is also going to move. So our fingers are going to point in this first vector, and then I curl them in the second direction, right, in my second vector. So if I have R cross F, that would be it, right, R, F. Now, that's if F points this way. If F points this way, I'm going to have to go R, F, right? And now notice how that changed the direction of my thumb, right? That is my final direction of the final vector, is how my thumb points. So R cross F gives me tau, gives me torque. A cross B gives me C, right? We're going to keep coming back to that. So I have a quick primer here on us. Let's do this. I'm going to point my fingers up in the direction of R, right? And I could point them this way, I could point them this way, I could point them this way, I could point them any which way. Let's say I point them this way for right now. I need to curl my fingers, I need to bend my fingers into the direction of F. And if you can bend your fingers back this way, go to the hospital. You have broken your hand, all right? You can't bend your fingers back this way. You need to go to actually turn your hand around, and now you can suddenly bend your fingers in the direction of F. So R cross F gives me, that's my thumb, right? It's tau. Tau is going out of the page towards you, right? Out of the page towards you. And that is how tau ends up working, right? And you can kind of do a whole slew of these examples, but generally speaking, R cross F gives me tau. That gives me a direction tau. Now, why is tau in a third direction? Why is tau pointing in or out of the board or the screen or our page, right? Why is tau, and it doesn't always point in and out of the page, but it will if R and F are in the X and Y directions. Why do we need a third dimension? Well, again, think about what's going on. We're starting to rotate, we're starting to spin, right? And I need to describe the way in which we spin as a vector. Now, the way in which we spin is usually either just clockwise or counterclockwise, right? Counterclockwise or clockwise. But those aren't, I mean, those are circular-y kind of directions, right? I need to have a way of describing this as a vector, a plus or minus, right? And so what we're doing is saying that counterclockwise, clockwise is now being kind of cast as a positive or negative in a third dimension. All right, we're translating this circular-y kind of motion into an in or an out. All right, so generally speaking, into the page, right? Into the page is going to be a counterclockwise, sorry, a clockwise. Into the page is going to be a clockwise way of looking at it. Out of the page is going to be a counterclockwise rotation. All right, so I did that for you, but if you're doing it at home, right, if you think about coming out of the page, I'm going to see a counterclockwise rotation. Into the page is going to be a clockwise, right? And we can just kind of use our thumb and curl around to talk about that motion, to talk about that rotating motion. So another pseudo right-hand rule there, right? Not only do we have r cross f gives me tau, but I can also talk about how my tau is going to give me an angular acceleration, right? Which way is that going to spin me? All right, so that was right-hand rules. Next time we're going to do a quick example, a rolling example, to start talking about how to use torques, and then we'll move on to some other things like rotational kinetic energy. All right, so have a good one. I'll see you back here in just a second.